is called your exponential and logarithmic relationships. All right, so to review, remember we have our exponential. So if I had something like x is equal to a to the y, that is the same as if I said a to the y equals x. You can reverse them, remember, that doesn't matter. What is the a called? Base. What is this called? Exponent. And this is obviously my answer. So when we have it in exponential form, we have to be able to write it in logarithmic form. And it's really important this chapter to be able to go back and forth. So to review our logarithmic form, the first thing you want to write are log. So when you say this, you say log base. So what's my base on this one? A. So log base A of x is my exponent, which is y. Your calculators are log base 10, and eventually our goal is to convert everything to log base 10 so we can use our calculators. That's our goal. But right now in this world, everything isn't always base 10. So that's what our goal is to convert everything to base 10 once we get there. So log base. So when you say this, you say log base A of x is y. That's how you would read this. All right. So now today we are going to be solving though for x. So we're going to we are going to example 1. We are going to convert and solve. So the first thing we have is our problem is log base 2 of x is equal to a -3. Now, one thing I really want you guys to realize is that there's an imaginary line here, and this 2 either starts at the line or is below the line, never above the line. So you want to make sure it's clearly a base. All right, so I want you to put that in exponential form. So quickly throw that in exponential form. All right, so my base is 2. Logs are, class, what are logs? Exponents. So this is my exponent, and there's my answer. So that means that what is 2 to the -3? Now this is important. You can throw that in your calculator, but it's very important to understand what exponents do. Does anybody remember what I said does with a negative? It flips it or puts it to the bottom, right? So this really is saying 1 over your 2 to the 3rd. What is 2 to the 3rd? 8. So that means x is equal to 1/8. So that means log base 2 of 1/8 is -3. Now, if you want to go to a table back in the day before they had the calculators, there's actually tables of logarithms because you have to use them for certain things, and they would have to go and look it up. So log of 2 of 1/8, that would give you your -3. All right, example 2. Example 2, we have log base x of 4 is equal to 1/2. So I want you to take a moment and to throw that in exponential form. So my base is x. Logs are exponents, so this is my exponent, and my answer is 4. So I have 4 to the 1/2 is x to the 1/2 is equal to 4. How can I solve for x? what is this right here? This is the square root. This is the square root. We have to raise it to the square. We have to get this to 1. So if I raise this, because remember you multiply these, so I am going to raise it to square. I'm going to square it. So x is equal to 16. So that means log base 16 of 4 is equal to 1/2. All right? So whatever this is, you're going to raise it to the reciprocal. So if it is 1/2, you raise it to the 2. If it's 2/3, you'd raise it to 3/2. So because you multiply those. All right, a last example, example 3. Or not, a last example of these types, because there's something else we have to learn. But last example of this. All right. And we are actually going to do 3 of these, because to me these are the hardest ones. Log base 3 of 27 is equal to x. So I want you to put that into your exponential form. I want you to quickly put this into your exponential form. All right, Caleb, tell me what it is. 3 to the x is equal to 27. Very good. This is the hard part. If you do not know how to figure out what they are, when it is a bigger number, it's somewhat easier, but it's saying 3 times 3 times 3, how many times gives me 27? And the answer would be 3. If you didn't know that, what you're really doing is in your calculator go 3, enter, times 3, enter, times 3, and count how many times that you are doing that. So it is 3 times. All right, I want you guys to try this one by yourself. When these ones are always going to be either a root, like a square root, a third root, a fourth root, or to the 1, 2, 3 integer. Yep. But it can be a fraction. So we have log base 3. Oh, no, 4. Sorry, I just did that one. Base 4, sorry. Of 64 is equal to x. So log base 4 of 64 is equal to x. I want you to try to solve that. All right, John, walk me through it. We have my, how do I set it up? Very good. I didn't write the answer. Yep, 3. Yep. No, because in your calculator, go 4 times 4, which is 16, times 4, which gives you the 64. So, yep, it's 3 again. And the last one is log base 27 of 3 is equal to x. All right, so we have 27 to the x is equal to a third, or equal to 3. So remember, it's either going to be a square root, a cube root, or things like that, a fourth root. So this right here is actually a third root, because it's 3. You could also say 3 times 3 times 3, which gave us the 27. We knew it was that, so that means we have to do the third root. So x is 1/3. Once I teach you all the properties of logs, the cool thing is there'll be another way to solve problems like this without knowing what the answer is. All right. If I had, yeah, actually I'm just going to, I don't know what I should call it example 4, but I'm going to. If I had an example that had an exponential, it says 10 to the log of 10 of 5. And I wanted to know what that equaled. So I have 10 raised to the log base 10 of 5. I want to know what that equals. All right. So some of you might already know because you're understanding what's happening here. But if you don't, we can call this x, right? Because we don't know what it is. It's unknown. This is exponential form, so let's put it in logarithmic form. All right, so let's put it in logarithmic form to see what's going to happen. So if I put this in logarithmic form, I have logs are exponents. So what's my exponent, which is log base 10 of 5, and then my base is 10, and my answer is x. So this is exponential. This would be like 10 to the 2 is equal to x. So this is my exponent. So logs are exponents. So this whole thing is my exponent. Okay, so I'm putting logs are exponents, so that's there. My answer is here, base of 10. So x is, what is x? X is 5. See, these are already there, so x is 5. So what the theorem says is if you have a base and it's raised to the log of that base, it's going to be that number. So if you did, we'll go B, if I had 2 log base 2 of 5, it's going to be 5. If I had 2 log, the answer is going to be 5. Yep. Time out for 1 second. Okay, just wait. Go ahead.
Why do you do like the log 10 of x? I just don't see.
Okay, this is where we started. That's our problem. Okay, this is my base. So I'm putting my base of 10. My answer goes here. This is my exponent is there. So then you're saying what is missing. And I will tell you a lot of these problems in the chapter is being able to remake it so that you can figure out, well, what is missing, kind of something like this. We're going to learn some more properties tomorrow, but that's what it's saying. So Ian, what about this is 5. So if I had what?
If you had like 2 log 4.
No, you have to have the same log. You have to have the same base. So that's the thing. This has to be the same as, not right now because we don't know enough. It might, but not right now. So it's going to be this is going to be the same base, so it's going to be 2, but maybe it'll be like 12. And the answer would be 12. But this has to be the same as that. Later down the road. And then we have to learn what properties we can use for that. Yep. All right. So the theorem, just so you know, I will write actually the theorem up for that one just in case some of you would like to see that. So it says a log of a of x is equal to x. So it's equal to whatever is there. And then log base 2 of a to the x is also equal to your x. So if it is, no, this is an a, sorry. Sorry, I couldn't read my own writing. So if it's the same here, it's also the same. And that's because when you put it in exponential, it would be a to the x is equal to a to the x, which obviously then x's are the same. So as long as your bases and your answer is the same, if it's raised to something, it's also that. So this is the theorem that will work. But you can always put it in exponential and you'll be able to see the answer. That's what we're doing today.